Howdy PreCal, it's Miss Kosh. I wanted to talk a little bit about day 2 of transformations. It's kind of day 2 of transformations has merged and become our review date, and we haven't, in this time of COVID, we haven't really made you graph by hand, and I think that that's an important skill. But I will tell you that the quiz that we just finished writing doesn't ask you to graph by hand because we wanted the computer to create it for us. Anyway, it is what it is. So let me remind you, I did post all the old videos that I made. So keep watching those. Just in a brief, we'll just make sure that the transformations kind of make sense. We did this one with a few kids in my room. And we said, okay, well, what has changed? We know it now has a vertical stretch of 3. It's got an its amplitude is now 3. The period did not change, and there is no shift left or right. But there is a shift up 1. And so you need to make sure, in order to graph this, you have to know the parent function. And so with the parent function, I want to see 5 things, okay? And I want to see, you can label them as ordered pairs. Technically, it keeps going. You could label them as ordered pairs, or you could label the graph and say this is pi over 2, this is pi, this is 3 pi over 2, and this one right here is 2 pi. And it goes as high as +1 and as low as -1. That would give you full credit for what I'm looking for. And so now, then the next thing that happened was that we stretched it. And so now, instead of it goes 0 and it goes as high as 3, it goes back to 0, it goes low as -3, and then it comes back to 0. And, okay, the period didn't change. Pretend I can, whatever, I'm not overly concerned. This is 3, this is -3. There's my tick mark. Well, okay. You would need to label, this is pi over 2, this is 3 pi over 2. And now all we need to do to graph the final one is to shift the whole thing up 1. So what was at 0, we now 1, 2, 3, 4, we now have this. We started, this point right here started at 0, and now it's moved up to 1. And so I'm going to go there, 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 and I'm going to go as low as -2, and then back to 1. And so this is now the graph, and I should label more. I'm sorry that that looks as bad as it does. They should pay me more, so if they did, I'd make this prettier. No, I'm just kidding. Well, am I kidding? Who knows? Okay, there's all of that, and that's how we would graph that. So this, in the past, what have I taken points off for? I've taken points off for kids who make it look too linear. That's no good. I've taken points off for kids who, I mean, as long as you are as graphed as well as I am, then you're fine. I guess that this one over here is definitely prettier than the other two. But I'd want to see, you have to somehow indicate, I'm aware that this is 1, 2, 3, 4. If you're going to change that, then you'd need to label it. Yeah, so I think you should practice graphing these. I think it will matter to you in the future. We haven't written the test, so we might ask you to graph by hand on the test. I will tell you that the quiz is entirely something the computer can grade. But I did put something where I gave you a graph and I ask you to fill in all the parts. And so it's more than like, so say I have, this is not on the quiz, but it's the same idea. Say I give you a, hang on, I'm just kind of winging it. Say I give you an equation that goes like this, and I tell you that this is pi over 2, and this is 3 pi over 2, and this is the point 1, and this is the point right here, 5. Okay, and so that's 1, so that's pi 1 or whatever. And I would label things and make this very easy for you. What if I told you that I needed you to write this as both a secant and a cosecant graph? Okay, so the easiest thing to recognize is that this would be secant, because the asymptotes, not the amplitude, the asymptotes match exactly for the parent function of secant. But what happened is now instead of, typically the gap goes from, well, typically the parent function, it goes as high, it starts at 1, and then here's at -1. Okay, and so this gap has a total distance of 2. Okay, so this is up 1 unit here and down 1 unit here, and that would be just y is equal to secant of x. Well, now this gap right here, from here to here, do you see what I'm describing? That is a gap of 4, which tells you, since this gap of 2 gave you a 1 out front, this gap of 4 gives you a 2 out front. So it's going to go up. So from the midline, this is not drawn to scale, my bad. But the midline through here, you would be 2 units above it here and then 2 units below it there. Not a 3, but anyway, whatever, I'm trying to show you. And so this midline would be y is equal to 3, which would tell you how much you shifted up. And secant right here doesn't do anything else, okay? There's no shift left or right. The period didn't change. We're good to go. If you had to write this as cosecant, so what I may have done is given you a box here where you have to fill in the number and a box here where you have to fill in the number, and I'm giving you lots of choices for which goes where. Okay, so you can't, it's not like multiple choice where you are given 4 values and 4 equations and you just pick which ones work. I've got it set up where you have to know more than that. So I had a lot of fun writing those questions, but I would grab scratch paper and try the problem. Maybe look and see what the choices are, because there's actually infinitely many ways that you could write this equation. So we don't want to do that. I have narrowed it down. Of the choices that I give you that go in the box, there's only one correct number that would go in there. But if you try and just guess through all of them, you got a whole lot of combinations and it would be a beating. If we were to write this then as a secant function, with this one, keep in mind, that's not secant, I meant cosecant. Cosecant does something like this, where this is at pi over 2, and here's the asymptote at pi, and here's an asymptote at 0, and then it's down here. Okay, this is going to have the same 2 and the same plus 3, because this graph right here, because it has still been, it's still been pulled apart from the x-axis and then shifted up. So those are going to be the same. Notice how those would both be the same, even if you switch to cosecant. But what's going to happen is that this parent function has to shift, this point here has to shift over to this point right here to match that. Okay? And so a shift left is what the parent what did I do to the parent function to get here? I shifted it left. Okay? And so this means I would say, how much did I shift left? I shifted pi over 2. And so I would say x plus pi over 2. Right there. And we can verify 2 secant x plus 3, okay. 2 secant x plus 3, and then I had 2 cosecant of x plus pi over 2 plus 3. Ha ha ha. Happy day, they match. And that's how we can use Desmos to help us check. So isn't that nice? Look at that. Turn it on and off, and there it matches. All right. Was there anything else I needed to tell you? That should get you started. Good luck.